Hi there. In this video, we will try to explain the physical phenomena of time dilatation to you. Discovered by Albert Einstein in 1905, it relies on his theory of special relativity.
But first, what is time dilatation? For this, we'll have a look at an example. The well-known Dagobert Duck sends all three of his nephews, Huey, Dewey, and Louie, on an exactly 1 year-long journey to help him further increase his enormous wealth. He gives every one of them a very precise clock, a light clock, while keeping one himself so they could return to Dagobert in exactly 1 year.
The first travels across the entire Earth and returns just fractions of seconds too late, but aids punctually with a lot of money. Dagobert's second nephew spent the entire year flying in an airplane, but he arrives 33 minutes too late, even though his light clock shows him that he's punctual.
His last nephew takes a spaceship that travels at 80% of the speed of light in order to retrieve faraway and precious minerals for his uncle. Dagobert and two of his already arrived nephews wonder why the clock on the plane had differed from Dagobert's own, while they await the last who doesn't come. After 243 days of hopelessness, he finally comes to arrive.
In order to understand this, we look at how a light clock works. It exists of two mirrors 150 centimeters apart, and a light beam with a steady speed of 300,000 kilometers per second, well, actually it's 299,792,485 meters per second, is being reflected to and fro between the mirrors. Depending on how often it reflects, more or less time passes. The beam must reflect 200,000 times for 1 second to pass.
If the light is in movement relative to the viewer, like Dagobert on Earth, we witness a change. Now the light must travel a longer way. The faster the clock is in motion, the longer the distance is the light must travel. This means that the clock ticks slower when it's in motion because the beam has an absolute speed. It needs longer to hit the mirrors 200,000 times.
Now we have a problem. Either the clock doesn't work if it moves, or the time just passes slowly. We can exclude the first possibility because the same would happen with all watches. Only a light clock is easier to illustrate. This was also confirmed in experiments. So the time must pass more slowly if you move, only because there is a maximum speed of approximately 300,000 kilometers per second. Time is not absolute, but relative.
Now finally we have solved why Huey, Dewey and Louie came at so different times, however their clocks are right. If you think it's unfair that Louie had more time, you're wrong, because time dilatation has an effect on everything, so also on a person, or well, ducks.
In the end, still a nice example of use. Time dilatation is not only something theoretical. GPS systems and other locational devices would not function without calculating time dilatation with a satellite's movement. It accompanies you, so to speak, daily.